Hey there, Mr. Kyle at MyersMathematics.com, and today our title is Why Are There Letters in My Math? Because that's a question that I'm sure we all asked at one point or another, sometime around middle school maybe for most of us. We started off with 1 plus 1 and ended up doing a little bit more complicated stuff as we go along. But then at some point we got up to maybe something like this, 4 squared, 3 divided by 3, I don't know, I'm just making it up as I go here, guys. So, you get with something like this, right? And then you still can just kind of put all the numbers together and find out what the answer is, right? You'd have to use something called PEMDAS at that point to make sure you're doing everything in order, right? Please excuse my dear Aunt Sally. Or you could call it parentheses, then exponents, multiply, divide, add and subtract in that order. But soon after doing those sorts of things, you're introduced to something like this. 2x plus 1 equals 7. And then there's this, right? And I'm sure you've seen a question like this before. The question is, find x. Right? So it's not just as simple as pointing to it, obviously, because if you ever did that on a math test, then your teacher probably told you were wrong and maybe thought it was funny, but realized that maybe you weren't paying attention in class. But anyways, why is that there in the first place? Well, let's solve this first, right? So 2x equals 6, because I would subtract 1 from both sides. And I would divide both sides by 2 and get 3. So x equals 3. Now, that means that x equaled 3 all along. X didn't equal some other number before. It's just that I didn't know what it equaled yet. That's the first kind of letter that you're exposed to. And usually we call letters variables. But we don't have to. I don't want to talk about variables. I want to just talk about letters. Right? So the first kind of letter that you were ever exposed to, most likely, is the kind of letter that has a value. You just don't know yet. That's the one that I just worked on there. Okay. So that's the first kind of letter. So at some point, you do a bunch of different equations, and then you come across a second letter. Y. Y equals x plus 1. Right? So you don't have to do anything with this, actually. You don't have to necessarily graph it. If you've already taken algebra, then you've probably maybe understood that you can graph this if you really wanted to. It would look something like this, right? More or less. But you don't have to graph it. It's not necessarily for sure a graph unless I do something like this to it and call it f of x equals x plus 1. Now I've eliminated the y variable as far as a letter, right? Just purely speaking in letter terms here, I've eliminated the y letter and replaced it with an f letter. So there's still two different kinds of letters here, but nothing really changed because a lot of times we can rewrite y as f of x, and that's how you would read this. But let me get back to that point. There's different kinds of letters, right? So why do we even have letters in math to begin with? That's the whole point of this. So the second kind of letter then is a variable. So x and y are purely variables here because I can plug in any number I want for x. And it just means that I get something out for y. And then of course vice versa with y. If I plug in something for y, that means x has to equal something else. So they sort of depend on each other. But really when I'm talking about functions, the x here is the what's called independent variable, meaning I change the x and it results in a change in y. And that's how you're supposed to look at it. But basically, variables are what you typically think of when you think of letters, right? So you have the independent, right? So the change variable. You have the one that changes, right? And then you have the one that changes because of the change, right? So that's a really simple way to say it. Basically, this is usually the x, right, or the independent variable, and then changes because of the change that I made. If I make a change in x, it results in a change in the y. So those kinds of letters don't equal just one thing, not like a regular equation does. 2x plus 1 equals 7. X just equals one thing. Here, x and y could equal, well, anything. There's really no limit. Now, when I graph them, then I kind of actually put a limit to it, and that's the next kind of letter that I want to talk about here, is a letter that represents something. It's a title, right? And this is actually kind of the last sort of letter there is, really, as far as generally speaking, I guess, to not get too complex here. But titles. Well, so for instance, there's the really fancy titles when you use bars on your letters, and you may or may not have ever seen things like this. But things like this, when you put extra bars in your letters, they represent number systems. Number systems. Which just means, you know, numbers like 1, 2, and 3 are different than numbers like 0.5 and 1/2 and 2.3 repeating, negative even. So numbers like those, right, 1, 2, and 3 is different. Those are easier numbers than 0.5, 1/2, and negative 2.3 repeating. They're just different, right? And there's a way to actually talk about how they're different, and that's what the letters that have bars around them do. They're called number systems. They tell us what kind of numbers there are. Those are titles. Another title might be for a system, especially if I have a recursive system. You might have heard of something called Fibonacci numbers, right? So a n, just bear with me here, equals a n minus 2 plus a n minus 1. It's the classic Fibonacci sequence here. You add the two previous terms to get the current term that you want. So if you're not familiar with all this just yet, if you're watching this and you're either not familiar with it because you haven't gotten to recursive systems yet, or if it's just been a while since you've been in school, no worries. The whole point of this is to show you that there's two letters in this equation, right? There's an A letter and there's an N letter. The A letter is going to represent a variable. The N letter also represents a variable. They're actually kind of one variable. The A is going to be a term, and what kind of term is represented by the N. So N is connected to A. That's kind of like their one thing. When you put a little baby number on the bottom right hand corner as opposed to a number at the top right corner to represent a power, when you put a baby number on the bottom right, it kind of helps to determine or distinguish between two similar letters, because I have three A's here, right? But those three A's are actually all different A's. The N and the A work together to create a new title and a new variable. So those are some different ways to use letters. And then the last kind of thing I want to talk about real quickly is Greek letters. Greek letters. So far I've only talked about English or Latin-based letters, right? So I should say Latin-based letters here, right? Latin-based letters. And of course I'm not going to talk about other letters of other languages and things like that, because other countries use letters to represent variables and other things like that in slightly different ways, actually. Math is not quite as universal as you might think. But for Latin-based letters, we typically use them for all the things that I've talked about here. And then for Greek letters, we tend to use them for kind of the same reasons. We actually use letters like pi to represent numbers, right? Pi is 3.14, blah, 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 1592653, so on, so on, so on. So it's just a number. It's a really complicated number, but it's just a number. It's not really a variable. It's sort of like when we found out that x was equal to 2, or was it 3? I forgot. It was 3, never mind. When we find out that x is equal to 3, x is not really a variable anymore. It's just a letter that's representing a number. It's exactly what pi is. Pi is just a number that's represented by a letter, because it's a lot easier to write one letter, pi, than it is to write out the whole number that it represents. It's actually impossible to write it all out, because it never ends and it never repeats. So that's one kind of Greek letter. But then the other kind is the true variable, which would be something like theta, which is sort of like an x for angles. It's typically what we use Greek letters for when we want to measure angles. So if I have a circle and I have some angles here, right, I can call them all kinds of things. I can call them alpha, beta, gamma, right? I can call them all kinds of different things until I find out what they are, and if they are something in particular, I should say, then they're really not that much different than pi, because pi is exactly one number. Or they could represent an angle that changes. It just depends on the context of the problem, what math you're in, how complicated the problem is, etc. But we also use Greek letters, and they can be variables or they can be constants. So all of that to get back to the whole point of this. Why are there letters in my math? So obviously, whenever you ask this question for the first time, it's really just out of frustration. You're not really wanting an answer. But why are there letters in math? Well, I mean, you've seen all the uses that I've shown you of letters, right? It makes math more complicated. And making math more complicated is initially kind of a bad thing, it seems. And if you don't like math, then yeah, it is. And that's fine. Most people don't need to really use letters to find out what they want to find out in real life, unless you're in a math-related field. But for people that are, letters are actually a really great thing, because the complexity also helps you to solve more complex issues. And that's why math gets more complicated, so that you can use it to solve more complex issues. And that's what letters are for. So that's it for today. This has been Mr. Kyle at myersmathematics.com. By the way, I'm thinking of launching a video a day in September on the topic of factoring, because I know that's one of the biggest things that I tutor. That's one of the biggest things that I see requests for. Responding to some feedback, and I think I'm going to do some factoring videos in the month of September and launch those so that you guys will have an exhaustive list and some tools that you need to be able to tackle any of those factoring problems, specifically trinomials, because it would probably take a lot longer than just a month to talk about every kind of factoring that there is: monomial, binomial, quadrinomial, etc. But in the meantime, stay tuned. And if you're a student and you'd like free answers to math problems, as long as it's not a test or a quiz, obviously, any sort of serious assessment, and as long as it's not during school hours, you can follow me on my new business-related Snapchat, where I answer questions that you have for math homework, math assignments, and things like that in general. You can follow me at Mr. Myers Math. That's my Snapchat, @ hashtag, whatever you want to call it. I'm not that social media savvy if you couldn't tell, but it's mr.myers.math, no underscores, anything like that, just the mr dot Myers Math, all one thing. And you can catch me on there and ask me questions for free on your math. Until next time.